Hello, Longhorns. Today we're going to take a look at trying to understand the transfer of heat. This is actually one of those topics that you guys have had before. If you think back to your elementary days, even middle school, we talked about if I touch something, how do you know it's actually hot? And how do I know if it's actually cold? And it's that difference in 1 degree or more that will give you your indicators as to whether heat is being transferred or not. This is lesson 19. We're coming out of chapter 9, pages 307 through 313. Now, one thing that we already know is that heat is always going to move from a warmer place to a cooler place. This goes back to that idea of equilibrium. Everything wants to be equal, and heat is no different. If you think about it, I want you to kind of put in your mind small particles. These particles want to stay together. So if I have 30 on one side but 10 on the other, it'll make more sense for 10 of those to switch places. And now we're even on both sides, 20 and 20. So, hot objects in a cooler room will cool to room temperature, and cold objects in a warmer room are going to do the opposite. So kind of think of that cold drink and the ice cube is in there. You're going to hear this question all the time. Does the ice cube melt because it's absorbing heat, or does it melt because it's actually giving away its coolness? And we'll learn the answer to that by the end of this particular topic. Now, we're going to use the letter Q, capital Q, to represent heat. And there are 3 ways that heat can actually be transferred: conduction, convection, and radiation. To keep in mind, conduction means that 2 objects have to touch in order for heat to go from one place to the other. It's a simple way to put it in your mind. If you are a baker at all, or if you've ever been in any type of industrial kitchen, or even your own kitchen, many of us have an oven that has the ability to use convection. Convection, if I think about a pot that's in the oven, it's going to be the circulation of air around it. You do not have to have 2 items touching in order for heat to be transferred through convection. Last one is going to be radiation. The first thing that normally comes to mind for radiation will be the sun, because that's going to be our largest source of energy. We can also have radiant energy in other forms. Some people will even think of X-ray as a type of energy because it does have the ability to go through tissues. So as we go through further, we'll talk about what happens when molecules are able to heat up and also cool down. Here's one of your examples for conduction. You have the ability to press play to kind of see what molecules like to do. And I'll give you the chance to do this at home, of course. The other thing that we're going to pay attention to is, why do metals feel different from wood? If I have a metal piece, for example, let's think about this rod. And if I'm also touching, for example, a wood block, for most of us, the metal is going to feel a little bit cooler. And it's something that we actually don't think about very often. But when it comes to metal and wood, the first thing you guys know is that metal is a conductor. Conductors allow your electrons to move freely. So it allows heat to move back and forth with no hindrance. Wood is going to be an insulator, along with plastic and some of the foams that we're thinking about as well. If I am an insulator, I am going to slow down the flow from one place to the other. So conductors are going to increase the flow, and then your insulators are going to do the very opposite. If we look here, we go back to a word, electrons. And we've heard electrons, protons, and neutrons before. If we have electrons that deal on the outside of your metal, you're going to figure out that they're going to drift and they move freely. When we compare that the metal is being heated, it's going to allow more motion. More motion generates more heat. And the word for motion in the back of our minds, of course, is the word kinetic. Now, your insulators, such as wood and plastic, do not have this big sea of electrons hanging out. So therefore, they do not conduct heat very well. Is it possible for them to warm up? The answer is yes. If I touch a tree and it's on a hot day, I am going to feel that that tree may be a little bit warmer than normal. But which one would warm up more? Something that's made of wood or something that's made of metal? And the metal would definitely win out in that example. Now, the other thing we're going to do is convection. What happens to particles in a liquid or a gas when you heat them up? Well, we have to put our phases back in our mind. So if you think about it, in a solid, these particles will be really tightly arranged, like in your metal or your wood. But for a solid or gas, you're going to have more space in between. The particles are going to spread out and they become less dense. And this is going to affect how quickly things can move. You will hear me use the word viscous. And viscous means that you have a liquid or even something that's kind of plasma-like that's able to flow. If I ask you to compare oil and water and which one has the ability to run faster, you would tell me that oil is thicker than water, which is correct, which means oil is more viscous than water. Now, cooler, more dense fluids are going to sink, and warmer, more dense fluids are going to stay where they are. We've learned before that hot air will rise, cool air will sink. Here in the South, if you pay attention to where your air-conditioned vents are located, you'll also see the difference. In Texas, our vents are going to blow down on us. But if you were in New York, Baltimore, or any northern state, you will notice that your vents are going to be in the floor. So it depends on the temperature outside and the expectation that the customer is going to have for either cooling or warming their home. So warm air will always rise. Cool air, of course, is more dense and will sink. Here's another example that we can see, and this is one that we're pretty comfortable with, and it shows you the flow. If I have a flame, then we know the molecules in the middle will gain more kinetic energy. The warmer they are, the more they're going to move. So they're going to circulate up and out. Some of this heat, of course, is given off as steam. Think about a boiling pot, and we'll talk about that concept in a bit. But you're going to also notice that I go from red arrows to blue arrows. So there is a movement of water. There's a circulation and a cooling of water. And to maintain this temperature, we have to also maintain this particular flame. Why is it windy at the seaside? And this is another one. Land is warmer than the sea. So I have my arrow that goes from being blue to being red. The land is going to warm the air above it as it rises. And this is why we tend to get that little windy breeze. So you may have to wear a light jacket if you're on the coast. The further inland you go, you would definitely want to strip that. If you also think about it, in many cities, you're going to have fewer trees, more buildings, and more concrete. And we're going to learn that certain objects, certain materials also have the ability to hold more heat. And concrete is one of those as well. How does heat energy get from the sun to the earth? And this is through radiation. It has the ability to travel. So there are no particles between the sun and the earth, so it cannot travel by conduction or convection. We have to have something to go in between or to bounce off of. Radiant energy falls in that category of not needing that in particular. So it has the ability to go from the solar system, no medium is needed, and then that energy can flow and impact the earth. Now, what does color have to do with it? If I put you outside in a t-shirt on a 100-degree day, and you had the option of a white t-shirt or a dark color t-shirt, which one would you pick? Most people will go with a white t-shirt. It has the ability to reflect more, so I'm less likely to absorb those radiant energy rays. I would definitely stay cooler. You can see this in different nations, depending on where you are. The more likely you are to live closer to a desert, you're going to definitely be covered because you want to protect yourself from the rays of the sun. But you'll also notice the materials are extremely light, and they're also light in color. So color does definitely play a role here. If it was metal, if you had shiny metal, a dull black color, or shiny black, and the question was asked, which of the following would be warmer after 10 minutes? Well, if you think about it, the shiny metal container would be warmest after 10 minutes because its shiny surface reflects heat. This is radiation back into the container. So what's inside of that container will definitely stay warmer. The dull black container would be the coolest because it is best at emitting heat. It's going to give it off. So that's going to be the big thing as well. Before you go, here's a YouTube video that does a really good job of breaking down conduction, convection, and radiation. What I want you to walk away from this introduction with is that heat is represented by capital Q. We also understand that heat has the ability to be transferred in three different ways. Conduction requires that two objects are actually touching. Convection does not require that objects touch. And then radiation, we're going to think about the rays coming from the sun. Take a look at the rest of your PowerPoint. Be sure to review your notes. If you still have any questions, you can email me, and I'll see you guys in class.